Okay. Gonna wait for people to be able to catch this as it starts. So just gonna wait for a few moments before get this started. So today I'm gonna solve another challenge, and this one was sent to me by Olle Segerdahl, or NXS Olle, on Twitter. And yeah, I haven't looked at it before, so I have no idea what's going to happen, and we'll see how that works out. So yeah, so I'm just still waiting for a few people to have a chance to connect before I start. So yeah, nothing's gonna happen for a few minutes while I spam Twitter and other channels. So yes, as the title says, I'm going to try to solve another challenge today without having looked at it beforehand. This one was sent by NXS Olle on Twitter, or Olle Segerdahl, and so I'm pretty excited to see what this is going to be about. And like, if you have any feedback, or I don't know, anything, just write it in the chat. Or if something's not working with the stream, like if the sound's bad or whatever. So I'm gonna give it a few more minutes, then I'll start and people can join in whenever they feel like. Yeah, that's a very good point. I'm gonna increase the font size. Yeah. Oh well. Let's get started. Okay. So, as I said, today I'm going to solve another challenge which I haven't looked at before. So I just have this 7-zip archive. So let's unpack it. Okay, so we have another archive called hints. Hopefully we will not need it. And then we have like 3 different binaries, I guess. Yeah, like 1 Linux, 1 Mac, and 1 Windows, and a README file. So let's check the README file. Say no more. Okay, after inspiration from Gunvel, that sounds very scary. The challenge is a simple socket server that protects a secret using a password. Objective is to get access to the secret without knowing the password. To run the server, first set environment variables secret and password. And if you're out of ideas, contact Olle for the password for hints. Okay, cool. So let's I guess then like all of these different binaries are basically just the same thing for different operating systems. So we will be working with the Linux one. So if we set the secret to flag and password to the best password in the world, and we try to run this. Oh, you need a port as well. Let's go for 4000. Okay, it started. Okay, and then we can connect to it. See what we get. Username. Ask for a password. Okay, and the access is denied. And if we actually would type in the correct password, still denied. Okay. So the goal seems to be to like bypass this username password part here. Interesting. So let's close down the server for a moment and start looking at what we have here. So it's a 64-bit binary. So we're opening it up in IDA. See what we have here. Okay, so we can immediately see that it's written in C++, so there's a lot of like library stuff, but doesn't seem to be a lot of like actually user created code. So that's positive. This is the main function. So this is like the main startup sequence. It gets the environment. Let's see if I can I increase the text size here. Oh, I don't know. Anyway, so it starts by getting the environment variables that we needed to set up, and assigns them to some strings, and then it gets the command line argument, the first one, the port, opens up a socket, and then you have this accept loop here. It starts listening, and let's see, yeah, here. So when it gets a connection, it outputs this like opened connection stuff, the stuff we saw here, like connection number from IP, port, whatever. And then it spawns off this thread with this function task1 as a handler. So let's look at this. Okay, so first of all, the argument is probably the socket, right? Yes, so this is socket, and this comes in here, and so we're just gonna, let's see, it's just used here and here. Yeah, those are equal. We'll just no. Okay, so the first thing it does is to call this login function, and the login function here, I guess it creates these strings, username and password, and it checks if, let's see, maybe it checks if the username is nudge nudge and the password is in this global variable, possibly. If this, let's see where this is accessed. It's okay, so they set up the they take it's actually the environment variable that we set up here in the beginning. So let's just check what happens if we do that. So the password, which we don't know, is QWERTY. Okay, so that's how you would beat it if you actually knew the password, but we don't. So we're gonna have to work around that. Okay, so let's look into this in more detail to try to see what happens here. This is always pretty messy with this C++ constructors and destructors with all these really long names. So how would this, okay, so here we're actually reading one line here and then reading one line here. So this is the socket we're reading from, and this is just, oh, this is just like a buffer on the stack. We have no max size, it seems like. So let's just try to write a really long password or a really long username. Okay, that did not work out. Let's look at this closer. How? Okay, maybe actually we didn't go far enough. We had a lot of buffers here on the stack. So actually what we're gonna do now when like testing this out is to make this like do this with like a proper technique. So we're gonna create, like, instead of communicating directly ourselves with the script, we're gonna write a script, and I'm using Pwn tools in Python, a really nice library to do these kinds of things. So we're just setting this up to connect to a host and a port, and then we'll just start out like this to give us some like interactive prompt just to double check that it works. So we start this up like this, and okay, so we have like the basis here. We have set up the communication with the server, but we want to automate this. So let's first wait until it asks for the username. So we do receive until username, and then when we get it, we will send, like, I don't know, 400 A's. What happens? Okay, still not enough. Let's see if anything. Oh wait, did it actually crash now? Oh, I went a little bit too fast. Let's start this up. And then we do it. No, it was just me that shut it down. Okay, so this idea was not working. I overlooked something. I think. Because that's... Okay, so let's look at this closer again. So we are let's take these objects one at a time. So this is like the string username prompt. And this is the password prompt part. And then we send this string here. Okay. But this is actually what's interesting, like how we read this. So what is... Oh no, okay, this actually reads this into a a C++ string, so it's not just a buffer. This is just misleading. So these are actually not. This is not actually a buffer. Like these are actual like C++ string objects on the stack. So yeah, that was a mistake. So what happens here? We have some kind of loop here reading. Let's name these variables. So this is the string we're reading into, and this is the socket we're reading from. So here is our buffer. We're reading 1 byte at a time. And what are we doing with this? Okay, we are just appending this to the current string. So it basically reads as much as it can, and then it finds the last space, new line, carriage return tab, and then I guess it like erases everything after. Okay, so not obvious right now how that would be vulnerable. So this is the string username input, this is a string password input. By the way, where does it actually output the flag when we do get this right? It was after the login. Yeah, exactly here. So if login is okay, they output this here. Okay. And this is set to 1, but then if we are if we don't do the right thing, we get the we set it back to 0 and return it. Okay. Okay, let's go one level back up and see if like there's any details here that we are missing. Like, I'm getting this really bad hunch that Ole has done something really subtle. But let's not allow this to hinder the process. Like, I guess what you could do, like if you did this like locally, you could probably do like a timing attack against the password comparison, but that's not really feasible. Like, we're assuming this is over network, so then that's not really doable. So let's see, are there any other interesting... What's this big block? Oh, this is just libc stuff. Okay. Yeah, so let's take another look at this oh, I think I probably misnamed these. But it's not really a big deal. Okay, so okay, what happens here then if there aren't any of these in the password? Let's look in the documentation here, what this particular function does and actually what it returns. So I can zoom in. So basically we give it like a bunch of strings and it finds the last position that's not one of those. And the return value, this is the interesting thing. The position of the first character does not match. If no such characters are found, the function returns string and pos, which is greatest possible value for an element of size. Okay. Okay. So it's like a until the end of string value. So a few things we should probably look into is what happens if one, the input does not contain one of these. Or maybe it won't. No, there you. Okay, so it does actually progress here without just just taking some time. So let's see what happens if we wait a little bit more, because now it went through the username part and then sent the password without any white space. And okay, so what if we don't send anything at all, and just wait? Let's let that run while we look at this again. So it calls this erase function. So the erase function starts at one position and just erases everything a certain number of characters, or yeah, in our case just until the end. So I'm just wondering here, because like if this actually returns npos, which is like the maximum value, and the add one, this should wrap around and erase the whole string, but that doesn't really help us at all, because that will just give us an empty string. So yeah, that's interesting. Now I'm actually like really... Oh wait, what are we doing here? What's this? Just... okay, it's just the initial value. I thought that if that was some kind of a global variable, then there might have been some kind of like race condition in this or so, but no, it's just the starting value of the string, which is just empty. So that's not going to help us either. So this is a tricky one. How would this, because like these comparison operators shouldn't really be vulnerable to anything, and the only place where we input data is here and here. And it's not outputting data like based on what we input, it just outputs static data. So there's not a lot of stuff we actually control, which is problematic. But let's look up again. So I mean, there's nothing really interesting going on here either. Okay, yeah. Let's just double check that it doesn't do anything fishy here before it starts. Doesn't really look like it. No, so it's probably these. Okay. I'm just reading the README again to see if I missed anything. Challenge is a simple socket that protects a secret using a password. Your objective is to get access to the secret without knowing the password. Yeah. This was definitely maybe as tricky as I would have expected. Let's just try something stupid, like if we set the password and the username to the correct one, and then we do this again, just see if anything interesting happens. Yeah, okay, access denied again. And then let's send like a really large input without any white space. See if anything interesting happens. Now I'm basically just like, I don't know, fussing kind of the server to see, to try to find anything to work with. Like, what if we send a bunch of white space? Probably shouldn't. I mean, it should really just abort on, or not really abort, but it should just erase everything. It shouldn't really be a problem. But since I'm basically out of any sophisticated ideas right now, I'm just like trying this. Okay. Wait, why does it when we read the input, do we check for like new line specifically? So why does it, or maybe it's about how it sends stuff. Okay, so let's try to think about like how this could even be solved. Like, what's the end goal here? So basically the end goal here is for this function to to return 1, or like for this block to not run. Yeah, that would basically be it, because like this value just returns, and then this thing prints out the flag. But this is maybe a little bit interesting that they are stored in the same place. Like, so this thing can throw an exception, but that would basically just, I mean, that would just like crash the whole thing. So like my my thinking is that if we could get this to like return prematurely somehow, then that would also be one way for it to be solved. But not really seeing how that would happen. Or so what's going on here? So here is here is where we fail, where it writes the 0 to the to the result variable. So why are there these like try blocks here? That's so let's just go for stupid again and send something way too big. Nope. Ah, okay. So maybe it's time to bring out those hints and admit that this is quite tricky. Since I'm not really progressing here and I don't really want to bore you too much, so I'm gonna see if I can get a message to Olle. Olle, hints please. So while I wait for him to respond to that, let's look this over again. So like where you really would like there to be some kind of problem is here in the readline function, but it doesn't, like I'm not really seeing it. It's like we're reading this 1 byte at a time, adding it to the string, and yeah, one thing we still haven't tried, like what about like null bytes? Will it act strange somehow? I'm not sure what I'm looking for though. Of course it can just like add those to the string, shouldn't really be a problem. So okay, so I got the password to the hints archive now. So let's try that. So what did I just extract? Those num put. So is this basically just the same thing written in Python? Okay, it is. Let's see how this helps me. Okay, yeah. So in this Python code, like here, it has like a try block over the whole username password checking, and if there's an exception, it will just pass. So this function will return none, and then this thing will work. So actually, I was kind of on the right track. So the idea is to get this login function to throw an exception somehow, and then, but I'm not really seeing, like, maybe unwind. Oh, okay, yeah. This is something that I'm not at all as good as at what I should be, like exception handling stuff. So basically, yeah, but it's basically that. So let's see how we could get this to throw an exception. So where were we? Here in the so so what kind of exceptions could we get it to throw? So basically, when does read return errors? So let's check that. okay, so this is the function we're calling, and when would number red be so this could be just 0 if we didn't read anything. So that kind of leads me to think that it should have worked to just not send anything, but like apparently it does not work, so a little bit confused. Like let's try this reasoning just on the Python hint that we got. So let's run it. Let's run the Python server. Oh yeah, of course. So the secret is flag and password is QWERTY, and then we change this to connect to, what was it, 8787, and we connect. Okay, so let's just add some like helping printout, because what we're aiming for is here, because this try block is catching the timeout thing but not the end of file thing. So if we would just not send anything, so how does this because like we can't really close the socket, because then we will not get the answer back. Like we could do that just as a start thing. Okay, this is and when would this return end of file? Let's check the Python socket receive. So let's start with just solving the Python one, and then apply the same technique to the C++ one. Wait, would it work to just send like this? Shouldn't really work, right? Oh no, shit. Okay, now okay, sorry, just managed to close the wrong window. I really thought that if I would just send nothing, the read function would return empty string, but apparently I'm mistaken somewhere. Oh, also I have to restart this. Okay, it receives the username, that's fine. And then when we not send anything, is that a timeout then? Let's print that out as well. Now I really feel like this should be much more easy than it is. So, like again, what I'm trying to do is for the receive function to just return an empty string. Okay, yes, yeah, so okay, it times out. Can we just do like an empty send or something? Oh yeah, okay. So by just calling send but empty, then, but let's see what happens then. So it reaches this, and so let's see what's actually returned from error none. So shouldn't this, yeah, so then it should actually print it should print the result if we would just oh no, okay, I'm stupid. It's actually crashing here, and that's why this thing is okay. I'm way too sloppy here. So yeah, we still haven't succeeded, because what actually happened was that I messed up the socket. It would basically be the same thing as doing this. Yeah. So if we close the socket, then we trigger the correct error. But then we don't get the I mean, there is no way to get the response back with the flag because we have closed the socket. So that's not really a possibility. So in what other cases do do we return end of file. So we need to send an empty we need to send something so that the server doesn't think that we have timed out, but we can't send anything because we want it to be like end of file. So how does that work? So accuracy will also end with an empty string if the connection is closed or there's an error. So what happens if we just send like a null byte? Then it actually receives null bytes since it uses read. And then we get the timeout because it will just keep reading that. So like at least now we kind of know where we're going, but still a little bit tricky. How does this, like in what cases except for closing the socket would this give us the flag, or like give us an exception? This is like such a corner case. Shouldn't really. So when does this Okay, so could this be related to like having multiple sockets open at the same time? Because it really doesn't seem like... Okay, just like for testing, if we would set this to receiving 2 bytes and we would just send 1, then it really should return just... No, it does. Okay, so it really does wait for... When does... Wow, this is... like... This just reminds me how strange some networking stuff is. And I feel like we're like really almost there, but it's just like some small thing. Okay, so it's not really a problem triggering the exception, it's just closing the socket. But as I said before, that leaves us without the flag, which is not really what we want. So what's this argument to the listen function? That's the same thing we're doing down here, right? But this is... Or is that just the TCP? Python socket listen. Let's just find out what this argument does. Listen. Connection made to the backlog argument specifies the number of queued connection. Okay. Could this be like if we, since this is run in a thread, like we disconnect the socket and then we connect and we get the same file descriptor and the thread is still running and we'll send data on it. Feels pretty strange, but I guess it could work. So the question is just like, how would you do that? If we like set up like a bunch of other threads which will just like connect and read, and then we'll do just hammer it with connections and so we create this function which basically just like connects to the server, reads from the socket, and then like close down again, and then we have we just start a bunch of these. Like this feels really stupid, but we're out of other ideas, so maybe we should do this in a more some kind of more structured way. I guess this has, of course, needs to we should be looking for the what does it say when it prints this out? Like it says secret, right? The secret is something like this, and so okay, let's try it again. Okay, this is not like the easiest thing to test, and so why do we set this to a larger number than like the maximum value is okay? And what is the equivalent thing that we're doing in the C program? This is like set sock opt. Let's see if there is some more information on this thing here. So we have the arguments. So the opt name is 20. And the opt value is 15. So what do we call it? Sock opt name. It's called. Yeah, the opt name. Yes, we need to check the header where we define this. Okay, let's just assume it's the same for now. So how, let's turn this down a little bit just to see if there's any indication that this could possibly work. I guess we should like just repeat this part. Also, we can simplify this. We only need to just close it to right away. And we're not interested in the result here, so we could just like loop this like 100 times. But I guess these, yeah, this has to be done like in parallel, right? Because this has to be opened after the socket is closed. So like this is like really a race condition thing. So yeah, this also needs to run like in parallel then. So we do this. Now this is really strange stuff. But okay. Yeah, so this should probably be running in a loop then, just like hammering with connections. And this should be trying to do the same thing. So the idea is to like kind of like, okay, so the idea is that what needs to happen is that one of these connections will start, get the file descriptor like 5 and trigger the error, and that would free up this descriptor, and at the same time one of these other things would connect and receive the data. So could this possibly work? We'll just add a printout here that it worked. So it reaches like the success part several times, but it's just sending on a broken connection. So let's just try to maybe just ramp this up a little bit. Still have, of course, no idea really of knowing if this works in a good way, because I guess the flag could just like fly by here in the output at any point, but just feels like this doesn't feel right at all. It's like something really strange with this idea. There's something about like how operating system works that I'm missing here that shouldn't really make this possible. It feels like yeah. So let's try to let's try to see if there's something written in this socket file descriptor reuse. Okay, so maybe I can do this in a more elegant way, though. The problem is that like this shouldn't really, like the timing is like way too precise for this to really work, I guess, because like yeah, let's stop this. This will not work. Okay, so Olle was kind enough to send me another hint. And that the answer was in one of these Stack Overflow articles I read. So first of all, let's get rid of this threading madness, because this can't possibly be a correct answer. It will end with an empty string if the connection is closed or there is an error. Yeah, but when would that be? Could be just like so here someone's like exploring this. So they have a server. So if we would just okay, let's start simple on this one. Let's do this. Send something, sleep a little bit. So why am I not getting the same results here? Like socket set timeout 15. Is there something about the Pwn Tools library messing stuff up? Can I just get like the sockets property? I'm really sorry. This it's not just really working out, is it? I mean, the read should really just return Okay, so let's talk about this. I just received a slight hint on this, and then let's go into the documentation here, and apparently, or like of course, we can shut down 1/2 of the connection, so we can just like shut down the right part while still being able to read from it, and that would trigger an end of file error on the server, of course. So basically what we're doing is just wait until it does for username, shut down the right part of the socket, and then read what's sent back. And what happens on the server is that it tries to read, the socket is closed, this returns an empty string, raises an error, which breaks out of this whole thing and throws an exception, which will bubble up to this try block, will be ignored, the function will return nothing, no error is found, and it will print the secret. And basically it's, as we've already understood, it's the same thing here. We have exception handling here. So if we change this client to connect to the given program, yeah, we get the flag there as well. So that's an interesting edge case thing. Like how you could trigger an end of file on the server while still being able to read the response. Yeah, I'm sorry this was a pretty slow solve, and that's basically what happens when you have this thing that relies on like one little trick that I don't really know about. But this is also exactly the kind of thing I would expect from, like, if say like inspired by Ginwell. He's a CTF player for Dragon Sector, really skilled Polish guy, and yeah, Olle, who made this challenge, is pretty skilled himself. So this is just the kind of thing I would expect from them. And yeah, so today I learned something new. I hope you did as well. Not got too bored of this slow solve. Yeah, and I mean, this is what happens when you do a blind solve. I have no idea what's coming up, so sometimes it will be more smooth and sometimes it will not. So yeah, but anyway, that's all for today. If you have any like feedback on the format, or like how this could be more interesting, please tell me. Like what I'm like aiming for right now is to just, you know, try to solve it as I would if I had been doing this in a competition or whatever, and just try to like think out loud, which works perfectly fine when you know what you're doing, but when you get stuck, it's more challenging. Anyway, thanks for watching this time. I'll stop the stream now, and have a nice day.